So oxidation and reduction reactions are a special type of chemical reactions, and not only are atoms rearranged in these type of chemical reactions, but electrons are transferred or rearranged between the reactants. So this is the way I say it, redox, redox. And because you're transferring electrons, you have to have a pair. Reduction must happen with oxidation. You can't just have a reduction and have just electrons coming from nowhere. These things must be paired together. Woo. Oxidation and reduction reactions, the loss of electron is oxidation. That means the oxidation number increases across the arrow. The gain of electrons is reduction. The oxidation number decreases across the arrow. This is peanut, and this is the actual size of peanut. Leo the lion, loss of electrons is oxidation. Leo the lion says grr, gain of electrons is reduction, get it? Leo the lion says grr. This is my own little lion at my house with a giant mouth. This is the actual size of her legs. And now she is eating so much that her belly is scraping the ground. Oh, Peanut. I've had to hide her food, and now anytime you walk by where I hide the food, she bites you just for good measure. She knows the food's there. Okay, if you don't like Leo the lion says grr, you can remember oil rig. What do you think oil rig stands for? Oxidation is loss of electrons. Reduction is gain of electrons. So this is what we're talking about. Moving on. All right, ladies and gentlemen. What you need to be successful in a redox reaction is you have to be able to assign an oxidation number. Remember that chemistry people, if they have one word for something, they're bound and determined to have 4 or 5. Oxidation number and oxidation state are the same thing. It's a number we give to every atom in a chemical reaction so we can keep track of the electrons that are gained, grr, and the electrons that are lost, Leo. All right, there are rules for assigning oxidation numbers. Here's the first rule. Any atom in its elemental form, please look at the periodic table. All the elements on the periodic table are in their elemental form. That means they have an oxidation number of 0. Copper has an oxidation number of 0. When phosphorus is a hunk of phosphorus, it has an oxidation number of 0. When potassium is just a metal hanging around, it has an oxidation number of 0. Guess where we write the oxidation numbers of atoms? Oxidation numbers go on top and to the right. Okay, are you ready for the first tricky thing that you have to do today? Tell me what these things have in common. What am I missing? Nitrogen. And one more thing, what else? Oxygen, thank you. Okay, these are all diatomic molecules. Diatomic molecules all have an oxidation number of 0. When you have a Hofbrinkel atom and it has bonded to another one of itself, it has an oxidation number of 0. Why don't you write that down right by A?
When they what?
When they appear like this, F2Cl2, Br2, I2, H2, N2, O2, their oxidation number is 0. Monoatomic ions have an oxidation number equal to their charge. Potassium has a charge of +1, so its oxidation number is +1. Fill in that blank, and then I'm moving on back to the next slide so I can draw a picture. You need to draw a picture as well. Ready? Okay. Do you recall when we talked about the charges of atoms? I'm sorry, the charge of an ion? We drew a big slope. And we said that group 1, 2, 13, 14, 15, 16, 17, and 18 had charges like this. Anything in group 1 has a charge that is +1. In group 2, it's? In group 13? Okay, these are the charges of the ion. That second rule that says B, monoatomic ions have an oxidation number equal to their charge. This is what we're talking about. Here's their charge. So anything in group 2 that has a +2 charge has an oxidation number of +2. Anything that is in group 13 that has an oxidation number of +3 has a charge of +3. So rubidium has an oxidation number of, fluorine has an oxidation number of -1. Okay, that's what I mean by that. Moving on. Nonmetals usually have negative oxidation numbers. Oxygen, this is really important, has a -2 oxidation number in all compounds, with the exception of peroxides when it is -1. Here is the only peroxide you have to worry about. Hydrogen peroxide. If you see oxygen in any other compound on the planet, for right now, that is not H2O2, its oxidation number is -2. -2. Hydrogen is usually +1 with metals. Non-metals, I'm sorry. With non-metals. So if you see hydrogen covalently bonded to chlorine, chances are the hydrogen has a charge of +1. What would the chlorine have? -1. Now, if hydrogen is bound to a metal, and it is in a compound called a hydride, the hydrogen usually is -1. What would sodium be? +1. The sum of oxidation numbers in a neutral compound equals 0. This is a neutral compound. It has no charge. This is not a neutral compound. This means that the sum of the oxidation numbers of the atoms adds up to -2. This is a neutral or a charged compound?
Neutral.
It is neutral. It is neutral. Okay, I think you're ready to move on. All right, ladies and gentlemen, I'm going to show you something that I think I invented, called the algebra method. Algebra method. I would like you to write it down somewhere because it will be very helpful for you. Here's how you are going to determine the oxidation number of every atom in a compound. And that is step 1 in all redox problems. You have to find the oxidation number of all the atoms. Step 1. List the types of atoms in the compound. So here we go. We have sulfur and we have oxygen. Here's something you're careful. Here's something you're very good at. Count the atoms. I see 2 sulfurs and I see 3 oxygens. Put the known oxidation numbers in parentheses. Use an X for those that you don't know. This is a tremendous help for you. Here we go, right here, star this. The rightmost atom has the known oxidation number. The rightmost atom here is this hydrogen peroxide? No, so oxygen is -2. Do we know what sulfur's oxidation number is? But we do know this. This is a neutral or a charged compound? Neutral. So the sum of the oxidation numbers cancel and it is 0. So I'm going to make an algebra equation. That's step 4. Write your equation. So 2x plus 3 times -2 is -6 is equal to 0. 2x is equal to plus 6. X is equal to plus 3. It's very important that you always put the plus signs. So now putting the oxidation numbers, we have plus 3 and -2. It does. 3 times 2 is a total of plus 6 charge.
I thought you meant going across. Not going down.
Okay. Everybody happy there? We're going to leave, well, actually, let's get this one out of the way right now. This is a trick question. What is the oxidation number of this molecule? 0. Can't fool you. Let's do this one. My first step is to list the atoms. I see a carbon, and I see an oxygen. I'm going to count them. I have 1 carbon and 3 oxygens. I'm then going to write the oxidation numbers that I know. This is the rightmost atom I know. It is not hydrogen peroxide, so it is -2 for the oxygen, and I don't know what the carbon is. 1 plus x is 1x. 3 times -2 is -6. What is the sum of the charges for this compound? -2. So when I add this up to make my equation, 1x plus -6 is equal to -2. X is equal to +4. This is -2. This is +4. You're doing the next one on your own. They write it where it is. I don't believe that's correct, though. I need to see everybody's answer. I think that's correct. Write the oxidation numbers where they belong, up above the atom and to the right.
Miss Adams, we need one more, please.
That's correct. Question was, how do you know if it's neutral or not? If it has no charge, all the way to the right, it is neutral. Do you need another?
Yeah. It's -1, right?
So I'm going to list my atoms. I see a nitrogen and I see an oxygen, then I'm going to count them. I see 1 nitrogen, 3 oxygens. The one on the right is the one I know. It is -2. I don't know nitrogen. I do know that the entire charge of the whole thing is -1. So multiplying this, 1x -6, adding everything together, I have 1x plus -6 is equal to -1. I want all my numbers on one side, so I'm going to add 6 to each side. So if I add 6 over here, these cancel. And then I add 6 over here, x is equal to -1 plus 6 is +5. So oxygen has an oxidation number of +2, and I now know that my x is equal to +5. +5. The numbers in the parentheses are your oxidation numbers. The numbers numbers in the parentheses are oxidation numbers. Let's, what? What?
Is that meant to work with any equation?
What?
With the algebra meant to work with any?
Anything. It'll always work. Sometimes you don't have to. Let's look at the worksheet that I just gave you and work through a couple of these together. All right, this is kind of tricky because for the first time you have more than 2 atoms in a compound. Will everything fall apart?
No.
I believe so. I think you can do this. The algebra method works all the time. Let's do the first one together. This is sodium chromate. I'm going to do my algebra method. I'm going to list my atoms. I see a sodium, a chromium, and an oxygen. Now I'm going to count them. I see 2 sodiums, 1 chromium, and 4 oxygens. Is this a charged molecule? No. So I do know that the whole thing is going to add up to be 0. I'm going to put in my known oxidation numbers. The rule was the atom to the right is the one that you know. If there are more than 2 atoms, the one to the left is also known. The one in the middle, you don't know. So oxygen has a usual oxidation number of, sodium has a usual oxidation number of +1. Chromium's in the middle, it is our unknown. 2 times +1 is +2. 1 times x is 1x. 4 times -2 is -8. I'm going to add these all up, and I know the whole equation equals 0. +2 plus 1x plus -8 is equal to 0. I'm going to simplify and combine these numbers. +2 and -8 is -6 plus 1x is equal to 0. I'd like all my numbers on the same side, so I'm going to add 6 to each side. These will cancel out. 1x is equal to +6. Remember, everything in the parentheses is my oxidation number. I've solved for x. It's +6. So the oxidation numbers would be sodium is +1, chromium is +6, and oxygen is -2. Let's look at the rest of this worksheet very quickly. Let's determine what we know and what we don't know before we do anything else. Do you know the oxidation number of this?
Yes.
Yes.
No.
No.
Yes.
Yes.
No. Yes. No. Yes.
Okay, what is the oxidation number of hydrogen? Look on your rules and tell me. It is?
+1.
It's +1 because it's hooked to a nonmetal, so we know this. What don't you know in this one?
CL.
Uh-huh.
And
Mn, we don't know, and
S.
we don't know. Why don't you try finishing this worksheet? Should I do one more for you? Name which one you would like me to do. That isn't the second one.
H,
SS.
H,
Okay.
S.
SS.
This one?
Yeah.
Okay.
Easy.
It's very easy.
Or are you just kidding?
Okay, you want to try a different one?
Yeah, do HClO4.
Okay, all right, we'll do this one. Okay. So HClO4, I see an H, a Cl, and an O. I'm going to count them. I see 1 hydrogen, 1 chlorine, and 4 oxygens. Is this a neutral compound? So it's going to add up to have a charge of 0. Now I'm going to put in my known oxidation numbers. I know the right-handmost is minus.
2.
Hydrogen is bonded in this compound to 2 nonmetals, so
Plus
it
1.
has a +1 charge. My chlorine is my X. 1 times +1 is +1. 1 times X is 1X. 4 times -2 is -8. Here is my equation. +1 plus 1x plus -8 is equal to 0. Combining these two terms, 1x plus -7 is equal to 0. Getting rid of the -7 by adding 7 to both sides, these cancel. 1x is equal to 7. Now I know I can substitute x for the number +7. So hydrogen is +1, chlorine is +7, and oxygen is -2. Ready, set, go.